This is part 3 of the review for factoring. So for example 4, we're going to talk about how to factor binomials using the difference of squares. So let me just say that when we're using the difference of square type of factoring, this is only for binomials that you have like x squared minus something that's also squared. So like a number that is like a perfect square. So this is like 4, 9, 64, 144. Those are perfect squares. And it has to have a minus sign in between to be able to factor where you can separate the x's and one has a minus sign, the other has a plus sign, and then you separate the a's. And I'll show you what I mean here. So like in this case, this is a difference of squares because there are two terms with a minus sign and 9 is a perfect square. Two numbers that multiply to give you 9 is 3 times 3. It's the same number. So that's why we call it a perfect square. So if we were to factor this, we would write our two x's down. One would have a minus sign, the other would have a positive sign, and then you would drop your 3's. So essentially I'm taking the square root of that constant. So in this case, if you notice, we can use the sum and product pattern to test this out, right? X times x gives you x squared. Negative 3 times 3 gives you negative 9. But if you take negative 3 and add it with positive 3, that cancels, which is why this doesn't have a middle term and there's only two terms. So that's it. That would be your final answer. Whereas like this one here, this is a 49. 49 is also a perfect square. If we do 7 times 7, right? The square root of 49 is 7. So we would separate them again, put our two x's down, one have a minus sign, one have a plus sign, and put the 7's down. And there we go. We're done factoring. Now, this one is a little bit of a trickster. Notice how the 4 here is also a perfect square. We know that 2 times 2 gives you 4. But the problem becomes that you have a plus sign in between. And this is what we call a difference of square, not the sum of squares. So we can't factor this using this property. In fact, you can't factor this at all. You can try, but I can tell you that you can waste a lot of time doing this. So this here is not factorable because of that plus sign in between them. So we're going to just say not factorable. So we can't factor. Now this one gets a little bit more interesting because 81 here is definitely factorable. 9 times 9 gives you 81. And then this 4 here is also a perfect square. So you can do 2 times 2 is what I notice. And the middle here is a minus sign. So this fits in the difference of square setup. So what we can do here is we have to take note of the 2 times 2 and the 9 times 9 to get those two constants there. So we're going to separate them. And one's still going to have a minus sign, the other will have a plus sign. So one will have a 9, the other have a 9 as well. We've got to put our x's down. But in order to get that 4 there, we need to have them both be 2's. And that's how you're going to get the 4x squared. Because notice if you multiply 4x with, 2x times 2x, you get 4x squared. And then if you multiply the rest out, you'll notice that the middle terms will also cancel. So that's why you don't have the middle term here. But if you take negative 9 and multiply it by positive 9, you'll get 81. So this should be the factors of these expression. And that's it. So if you want to practice some more, feel free to try out the questions down below in the jigsaw section. It just means that we're going to be working these problems in class to do some extra practice, but I've already have them worked out in the notes for Journal 0. So please check that out if you want to see how each of these problems are worked out using the skills that we've learned in the previous 3 videos. All right, guys, I hope this was helpful. Bye.